Alright, welcome to the newest series on the channel. We'll be building a full enterprise level CI/CD pipeline from the ground up. Everything in this series is based on the same patterns and tools I use as a DevOps engineer. The application itself is an infrastructure project tracker. It's not proprietary, but it is intentionally designed to look and feel like something that you might find in a large organization. Before we get started, we're going to take a look at the high-level architecture and the tech stack. So if we look here at the architecture diagram, we can see that user request will enter the Nginx front end. Nginx here is serving as a reverse proxy, which will serve the React front end. And any API calls like searching or saving get proxied straight to the back end through the API route. Now, the back end is basically an express app written in TypeScript. It handles all the business logic and it talks directly to the cloud SQL managed Postgres instance, and it's connected over a private IP through a peering connection, which will be established in GCP. So the database traffic never touches the public internet. This application will be deployed in 3 different environments, dev, stage, and prod. Each will get its own unique namespace within the cluster to keep everything logically separated. Now, the version of the app that we're going to look at in this video is containerized and it'll be running locally. We'll use Docker Compose to spin up the entire stack, front end, back end, and Postgres container. That way you can develop it and test it without touching any cloud resources. The app itself will have the same code as it would if it appeared in our GCP provided cluster. The only difference is we're going to be running it locally first just to make sure everything is tested and working properly. The Docker Compose file that we create with this application for testing will use port 3000 on the browser to access the application. And then from there, it'll communicate with the backend over port 880. And the Postgres SQL will be running on 5432. That way we can properly route traffic between all the major components. So basically, in summary, this project is designed to run in GCP over a GKE cluster. And that's the way it's designed. However, just for local testing, we're going to use a self-contained Postgres instance. Okay, but when we run this in a CI/CD pipeline, we'll switch over to a cloud service provider offering, which is Cloud SQL. Okay, so the application itself has 3 major components. It has the React front end, the Express back end, and the Postgres SQL database. The front end and the back end will get their own Docker files, and the Postgres SQL will use a stock image pulled by our Docker Compose file. Now, if we scroll down a little bit further, we can take a look at the multi-stage build setup. In the front end, the first stage will run a full node image, which is basically a lightweight Linux container that has Node.js runtime and NPM already pre-installed. It's going to be used to install dependencies and compile the React application code into static HTML, CSS, and JavaScript. This node image is a little bit heavier than we'd like, but it has everything we need for the build. But none of that will be brought into production with us. So in the second stage of the multi-stage build, we're going to use a lighter weight image, which is Nginx Alpine, and we'll bring down the image size, and we'll create an image that will handle just the incoming traffic on the front end, and it'll proxy any API requests to the back end. So it's a little bit more of a simpler image than that we end up with. And in the back end, the second Docker file, we also start off with a full node-based image, and it will be used for a similar process, but this time what we're going to do is compile the TypeScript code. Now, the second stage, if you notice here, also starts off with the node Alpine image, but in the Docker file, we're going to use the npm install -- omit equals dev command, which is only going to install the production dependencies. So we're not actually running another full-blown image. This is actually going to be much more lightweight, and it'll copy over just the compiled code that we need only from stage 1. Now for Postgres, there's no Docker file at all, since we're just going to use an official Postgres image straight from Docker Hub, and we'll let Docker Compose can handle the configuration. The database name, user, and password information will all get stored as environmental variables locally because we're only using this for testing, but it makes it much easier to test and set up. Now keep in mind, when this application gets moved eventually to the GKE cluster on Google Cloud, this stock container will get swapped out for the cloud service provider offering, which is Cloud SQL. So this will just be for testing, and this will get replaced in the official cluster. Okay, now we're going to take a look at the routing for the application. We're going to discuss briefly how all the components talk to each other. So every request from the browser goes through Nginx first. Nginx is the front-facing component. It's the only thing that the user directly speaks to. When someone visits the application site, Nginx serves up the static front-end files like the HTML, CSS, and JavaScript, all the files that make up the user interface. However, if the user needs to interact with the database, like in order to search for a project or create a new project, that request gets proxied through Nginx to the back-end application via an API route. The important thing to remember here is that the browser never talks directly with the backend, and the backend never faces the internet. So everything flows through Nginx. And the backend operates in isolation. Its only job really is to handle the logic and communication with the database over a private IP connection in order to read or write data. So no public traffic ever reaches this. Okay. All right. So next we're going to take a closer look at the actual source code. And then we're going to actually run this application in a sandbox environment and then take a look at the UI. All right, so what we've done here is we've cloned the project repo into a sandbox environment, and we're just going to take a quick look at the Docker files and the Docker Compose files so we can just get an idea of how this application is put together. So what we're going to do first is go ahead and go into the front-end directory, and then from there we can take a look at the Docker file. And as we can see here, we're going to start off with a node image so that we have the tools to build our React code. We're using Node 20 Alpine version as the builder. And all the work is going to be placed inside a directory called app. From there, we're going to copy a list of all the dependencies, which will help us with caching later. And we'll install everything the app needs to build with the npm install command. Then we're going to copy the rest of the source code into the present working directory. We're going to turn our React code into the plain the HTML and CSS and JavaScript static files that you'd see in the final product of the website. Then in stage 2, what we're going to do here is use a smaller image, which is the Nginx Alpine. And we're only grabbing the built files that we built in stage 1, carrying those to stage 2. And we're going to hand them over to Nginx. We have a very special Nginx configuration file that we're going to use as well. And this will be exposed on port 80. And this command here is just going to start Nginx for us and keep it running. Okay, so that's just a quick overview of the front end of the application. Then we're going to go ahead and back out into the hierarchy, into a higher directory, excuse me. Then we're going to cd into the back end, and then we're going to take a look at that Docker file as well. Okay. All right, so if we take a quick look here, we're actually using Node again as our builder. We're going to copy everything into the app directory, and we're going to install everything we need to build with the same npm install command. Now, unlike the first Docker file, we're using TypeScript in this one. Okay, so when we do our npm run build command, we're going to be turning our TypeScript into plain JavaScript. Then in stage 2, we're actually going to start with Node 20 Alpine again, but if you notice down here, we have a slightly modified npm install command. This command is actually going to be a lot lighter than just a plain npm install. So whenever you add that -- omit equals dev command, it'll only install what we need to run and skip a lot of the build tools. Then the compiled code from stage 1 is going to be copied into our directory containing the dist folder, and then the backend is going to be listening on port 880. And this command here is going to make sure that we start the application and keep it running. So if we take a quick look here at the expose command from the previous one, if you notice here, we're exposing on port 80. So Nginx is going to be listening on port 80. And if we come back to the backend folder, we'll see that the backend will listen on port 880. Okay, this is going to be important later when we go through the Docker Compose file. Okay, so we're going to go ahead and stop here. And then next, we're going to take a look at Docker Compose. Okay, so now we're going to go ahead and look at the Docker Compose file. We're going to go ahead and pull together all of those containers that we went through earlier, and then take a look at how the Docker file kind of pulls everything together. So for the application itself, remember we're running 2 separate containers, and we're running a instance of Postgres database. So Postgres SQL database is actually going to be a official image from Docker Hub. So we're not actually going to create a separate container. What we're going to do is we're going to use the Postgres 15 Alpine image. So this is a standard image that we're going to grab from Docker Hub. And as you can see here, we have our environmental variables hard-coded. Now this is done intentionally because this will never be used in production. This is just for local testing in a sandbox environment. You never want to hard-code any variables, any secrets, or anything like that into your source code for obvious security reasons. The only reason you're seeing it here is just because we're running it in an isolated, completely separate environment. Okay. Now, Postgres SQL is going to run and listen on port 5432. That's a standard port. In addition to that, we'll run this SQL file the first time the database starts. So that is this location right here. And then we're going to keep the data around between restarts. So that's why we have this here. And then as far as the health check is concerned, we want to make sure that the database is actually ready to take connections. So we kind of have a built-in command here that's just going to give us a little heads up that it's ready to start. And then we have all of our retries, intervals, and timeout information beneath. Okay. Now, when we reference the backend, as I showed you before in the Docker file, we're going to listen on port 8080. The backend finds the database by its service name. So if we look down here, we can see that we have host is Postgres, the name, the user, and the password are defined here. So this backend instance can find and access this container here. Okay, so that information has to match. And then if we go down to the front end, we'll see that the build is from our front end folder. Okay, and it's going to listen on port 80, but it's going to be accessed on port 3000 in our browser. Okay, so we'll start the back end. Start the front end after the back end is up and running. That's what depends on refers to. Okay, and last but not least, storage for the database files is referencing Postgres data. Okay, so that's kind of a quick overview of the Docker Compose file, and then we're going to go ahead and run it and see the app load up in real time. Okay, in our last video, we went through the Docker files and the Docker Compose file that make up our app. Now what we're actually going to do is run the Docker Compose file so we can see the build process in real time. As you can see, I'm in the proper directory that actually houses the Docker Compose YAML. And what I'm going to do here is run a modified Docker Compose up command. As you can see, I use time in the very beginning and the build-d flag as well. And the reason we do that is without the D, the -d flag, the time command won't finish until we manually hit Control-C to stop the container, which would mess up our timekeeping. We want to monitor how long the build takes. So we need to have both the time and the -d in the command. So we'll go ahead and run the application, the application build process. We'll watch it, and then we can see all of the layers being built, all the containers being spun up, and then we can actually test out the application in our browser. So let's take a look. All right, so it looks like the build process finally finished. So now what we can do is go ahead and check out the application by going to the traffic ports tab in the top right, and we can go ahead and access the designated port for the application, which is port 3000. And we should see the application running. Okay, so I had to resize the window slightly so that everything would fit in the frame. But when you load the initial page in your browser, everything you see, the layout, the buttons, the project list, everything is being served via the front-end container. That's basically Nginx handling the inbound traffic to the React app. And as you click around, the page needs data. Like, for example, here I'm clicking on individual projects, and they're pulling the unique project data. That's all referencing the back-end container. That's Express doing the work behind the scenes. The backend then reaches back to the database, the Postgres database, and it provides all of the actual project info, comments, as well as live file information here as well. The backend sends it to the front end so that we can view it, and everything is in one easy-to-use user interface. So just want to demonstrate all the components. If you'd like to play around with this container, or if you'd like to use it in your own pipeline, just go ahead and leave a comment or send me a message, and I can make sure that you get this image so that you can test this out on your own. Okay. All right. So next, what we're going to do is look at the results of the build and see if we can make any improvements, see if there's any red flags, and just kind of take an overview of what we just built. Okay, now that we've seen the application up and running and we know it's working, now we can go ahead and take a look at the build and address any issues that may have occurred during the build process. If we scroll back up to the beginning, we can see that there were some vulnerabilities that were found in some of the NPM packages. If we look right here, we can see that there were, 15 vulnerabilities found, 6 moderate, 9 high. So it actually has the command to address those here. But first we need to make sure that NPM is installed. So what I'm going to do first is run the apt install npm command first, since this is a sandbox environment. And then after that finishes, I can then enter the fix command. So this will just take a few moments. Okay, looks like that completed. Now I'm going to run npm audit fix. Alright, now this is occurring because, let me see here, I have to be in the directory where the source code is. So let me go ahead and quickly move into that, and then we'll retry the command. Okay, let's give it a few moments here. Okay, now based off this report here, we're able to reduce the amount of vulnerabilities down to 2 moderate severity ones. And let's see, it also gives us a command to remediate those as well. So we're going to do audit fix force. See if we can address those as well. Okay, so with this information, we can update our source code for the application before we put it into our pipeline. So we've actually implemented some of our shift left philosophy by implementing the npm fix locally. Okay, so next we're going to check out the image and see if there's any common vulnerabilities found in any of the images that we're using. And for that, we're going to look at a tool called Docker Scout. Okay, so stay tuned to the next video. Okay, so in our last video, we ran npm audit fix in the front end folder, which initially flagged 2 moderate severity vulnerabilities that required a breaking change to patch. We followed that up with an npm audit fix with the force flag, which bumped Vite to version 8.07, I believe, right here. And despite some peer dependency warnings, the rebuild came back clean with 0 vulnerabilities. And our application is now patched and ready for another set of testing we can do with Docker Scout. So before we begin, I just need to make sure that I have Docker Scout enabled, and I do. I ran this command earlier, Docker Scout version, just to make sure that it was installed in my system. So now what we can do is run a vulnerability check in our individual directories and see what kind of results we get from Docker Scout. So I'm going to go ahead and use the Docker Scout quick view command in the front end folder, and we're going to run this and see what it identifies. I need to log into Docker first via Docker login. Okay, not a problem. Let me go to another tab here and let me log into Docker. Okay, this is going to give me an access token in just a moment. All right, so the one-time code has been entered, and we should have access here in just a moment. Okay, now I'm going to go ahead and run that same command I attempted to run earlier, and let's see if it works this time. Okay, let's give it a few moments. Okay, and as you can see, it runs a rather detailed report that lets you know about some information about the base images. Okay, so the images, Alpine and Alpine Slim. So the base image we used in our application was Nginx Alpine and its updated image is Alpine Slim. Okay. Now, if we want to view the vulnerabilities, it actually gives us a command we can use here, which I'm going to go ahead and paste. Okay, so this is a little bit more detailed information. Okay, so here we can see that we have 4 vulnerable packages with a total of 14 vulnerabilities. It lets you know the level of severity. I'm just going to scroll through these. Okay, and apparently you can also get some base image recommendations, so we'll take a look at those as well. Oh, okay, great. Okay, so this is exactly the type of information we want to use if we want to harden our the current images that we use in our Docker files, and it also gives us some other alternatives as well. So what we can do is take this information and we can rebuild the images based off these recommendations before we even begin to build our CI pipeline. That way, this will save us time in the long run. This will prevent us from having to do multiple builds, and this will make our process a lot more efficient by employing this shift left methodology into our process.